Hello everyone, welcome to this episode of Geospatial Solutions Training presented to you by DJI Enterprise. This is Ron Lee from Solutions Engineering Team, and this episode I would like to talk about horizontal coordinate system. Okay, before I start deep dive into all the concepts of horizontal coordinate system, talking about different types of coordinate system out there for vertical side, I do want to spend a few minutes here kind of emphasize the importance of knowing your horizontal coordinate system when capturing the data and when outputting the data. Because every single data you captured from a drone system, they're all going to be geotagged. Usually in a format of longitude, latitude. Let's say if you take a photo. That photo has a longitude, latitude embedded. That's your coordinate. But that means nothing without a coordinate system to define it. Because every single coordinate captured is associated to a specific coordinate system. Now, if you don't know the coordinate system, you don't know the reference at all. That's just plain number. So knowing your coordinate system is going to be important. Let's say if we have a project and we're using drone to collect all the data in coordinate system A. And we also have ground equipment collecting all the data in coordinate system B. Now you have probably always been using coordinate system B. Now you're getting this data coming from a drone system which uses coordinate system A. You'll probably guess the result. These two data won't match, and you will probably see a major spatial shift of your drone data compared to your project data. This is the part where you probably start wondering, okay, am I getting inaccurate data coming from the drone system? And no, you're just using a wrong coordinate system. So it is important to know your coordinate system, because that way you'll be able to manipulate your data. You'll be able to transform your coordinate system A data to coordinate system B. That way you can apply your drone data in the project and compare data between. Okay. Let's have a look at what we're planning to cover in this episode. We would first talk about horizontal coordinate system and talk about the two different types of horizontal coordinate systems, and they are GCS and PCS. And then we're going to compare between two horizontal coordinate systems and which one you should be consider using. And then I'm going to cover some commonly used practical horizontal coordinate system out there you often see. And I would also cover some frequently asked questions about the horizontal coordinate systems. So there are going to be two types of horizontal coordinate system used to describe locations on Earth. Same objective. You're trying to find or pinpoint a target location relative to the Earth. Just two different methodologies. That's why you have two types of horizontal coordinate systems. The first horizontal coordinate system is going to be called geographic coordinate system, or some people call it geodetic coordinate system. In short, GCS, which uses an ellipsoid model to describe the Earth. And when you're trying to pinpoint the location of your target, it uses latitude, longitude to determine the location of your target. The second method is called projected coordinate system, PCS, which instead of using an ellipsoid, it uses Cartesian XYZ axis to determine the location of your target in 3D space. So let's first have a look at the geographic coordinate system or geodetic coordinate system. Every single coordinate measured by the geodetic coordinate system include these three elements: longitude, latitude, and height or altitude. Now, since we're going to be covering horizontal coordinate system So that is going to be the longitude and the latitude values. Usually when you see the coordinate of a geodetic coordinate system or geographic coordinate system, they are represented by degree decimal or degree minutes seconds. So for example, on the right side, that blue dot has a coordinate of 40 degrees west and 40 degrees north. So that's the latitude and longitude over there, representing the angular measurement, and you'll be able to pinpoint the surface on the ellipsoid based on these two values. And because the geodetic coordinate system uses reference ellipsoid, and when you have a different reference ellipsoid, you have a different kind of geodetic coordinate system. That's why you have many different geographic coordinate systems exist. For example, some commonly used ones are following. For example, World Geodetic Coordinate System 1984, or in short, WGS 84. That is a commonly used one worldwide. And we have North American Datum 1983, or in short, NAT 83, is also a commonly used one, but for the North American region. And we also have China Geodetic Coordinate System 2000, or in short, GCS 2000, that is widely used in China. So as you can see, these systems exist based on different reference ellipsoid, and they're used differently based on the region. Now let's have a look at the projected coordinate system. So instead of using the longitude, latitude, and altitude as components, the projected coordinate system uses x, y, and z with linear measurements to determine the target location on Earth. So on the right side, as you can see, I have that same location marked, but now present in projected coordinate in x, y. And usually, since these are linear measurements, they came with unit meters or feet. But now you may have a question. Since the Earth is not going to be a perfect ellipsoid shape, nor it's flat. So how do you project the surface of the Earth on a flat sheet of a paper for measurement? So it turns out there are multiple methods for doing that. That's why we have multiple projected coordinate systems. But depends on which method you select from. These are going to be the three major or common ones that we see in practical use. The first one is going to be Universal Transverse Mercator, or in short, UTM method. The second one would be State Plane Coordinate System, SPCS method. And third one would be the Gauss-Kruger coordinate system. So these three methods are the most commonly used and practical methods when it comes to projected coordinate systems. And the UTM is applied worldwide, and SPCS commonly used in the United States, and Gauss-Kruger coordinate system commonly used in Europe, Russia, and China. So as you can see, different regions prefer different methodology when it comes to projected. And I will be talking about the reason behind that. But before that, let's have a look at each one of these. First, let's have a look at the Universal Transverse Mercator UTM projection, which is used worldwide. The UTM projection divides the entire world into 120 zones in projections. Each zone would have 6 degrees wide, and the UTM projection divides the north and south region based on the equator. Let's say if I want to apply UTM projection in where I live, which is Los Angeles, that will simply be zone 11 north, because I'm on the north side of the equator. So that is going to be my UTM projection zone. Next, we have State Plane Coordinate System. So unlike the UTM projection, which applies to the entire world, the state plane coordinate system only applies to the United States. And when most people talk about the local coordinate system, very likely they're referring to this. And for most of the engineering project, surveying project, construction project happening in the United States, this will be the system they use. And depends on where the project is, they will be choosing the local coordinate system correspondingly. And the last one is going to be the Gauss-Kruger projection system, which is also a worldwide projection system, similar to the UTM projection. It's commonly used in Europe, Russia, and China, with both 3 degrees and 6 degrees white zone available. Okay, so after we have talked about projection coordinate system and geographic coordinate system, you may wonder why use projection over geographic, since geographic is going to be global and projection is going to be regional. Well, from 3 aspects. First of all, accuracy. The projection system can minimize distortion. When you're projecting the Earth's surface on a certain region, projection has an advantage of minimizing the distortion, making the results more accurate. Secondly, it's more convenient because you're measuring everything in length units such as meters or feet. However, with GCS or geographic coordinate system, everything is in degrees. Thirdly, is because of legal and historical reasons. You may have land ownership difference, legal documents and many existing maps having conflict, for example. So that's why certain regions prefer to use projection over the geographic coordinate system. Now let's compare between geographic coordinate system and projected coordinate system, and under what scenario you would use one over the other. Geographic coordinate system is commonly used for global positioning and global navigation. It is ideal when you want to represent a position of your target in a worldwide scale, as it takes account of the Earth's curvature. Now, when it comes to projection coordinate system, which is commonly used for mapping, land surveying, where detailed, accurate representation of your property is going to be needed, projection coordinate systems are more practically used in those. So when it comes to local surveying project, when it comes to construction, civil projects, those will be the scenarios commonly used projection coordinate system or local coordinate system. Next, let's talk about some commonly used horizontal coordinate systems out there with some examples. So it depends on the location of your project. You may be asked to use or apply a specific horizontal reference to your project data. That could be, again, geodetic or projected, but that can also be in a global scale or regional. So taking United States, for example, if you have a project that is located within United States, very likely you're gonna use following horizontal reference. First one would be WGS 84, which is in a global scale that not only applies to United States, but other regions as well. NAD 83, that is a horizontal reference frame that focuses more on North America side. And you also have this NATRF 2022, which is meant to replace NAD 83 in future. WGS 84, which stands for World Geodetic System 1984. It is a global horizontal reference frame which is commonly used in the world. And DJI Enterprise products, including drones, cameras, and lidars, all natively use this WGS 84 geodetic coordinate system for all the data geotagging. So let's say if you take a photo from a DJI Enterprise drone, when you have a look at the image property, and you'll be able to find its latitude, longitude, which is the coordinate of that specific image taken, and that coordinate was logged using the WGS84 coordinate system. So you can have mostly commonly known WGS84 in geodetic coordinate system form, which show you latitude, longitude. You can also have projected coordinate system form of WGS84, shows you x, y. For example, using the UTM method, like I covered earlier, you can have UTM WGS84 projected coordinate system to work with. NAD83, or people call it NAD83, it stands for North American Datum 1983. It is a regional horizontal reference frame people use in North America for their projects. If you have your project located within the United States, Canada, and Mexico, this will very likely to be the coordinate system you work with. So it also has its geographic coordinate system form as well as projection coordinate system form. At this point, I'd like to kind of talk about the state plane coordinate system we were talking about when we covered the projection coordinate system. The state plane coordinate system is referring to NAD83 in projection form. So, for example, you have California zone number 5. That is pretty much referring to the NAD83 projection for such a zone within California. When you import your data into software for processing, you need to define the coordinate system of your data. So for example, in DJI Terra software, which is a photogrammetry software you can use to process all the images and output a model or 2D map. For example, when you import all the images into DJI Terra, you can define your embedded coordinates within the metadata is from which coordinate systems. So we have a list, for example, in DJI Terra software for you to select from, and you will be able to find whether your data was recorded using an NAD83 geodetic coordinate system or WGS84 geodetic coordinate system. So on the right side, I have a screenshot from DJI Terra software to show you we have a list of NAD83 2011 state plane coordinates listed over here. Now these are the state plane coordinates that we were talking about. So that's the NAD83, again, mostly used in North America. Okay, at the very end of this episode, I do like to spend a few minutes here talk about some frequently asked questions are related to horizontal coordinate systems. The first question I have is, how does the geodetic coordinate system, GCS, handles the Earth's shape? The answer is it uses an ellipsoid model to interpret the Earth, and by knowing the origin point of that ellipsoid shape and the coordinate, which is longitude, latitude, you'll be able to locate the target anywhere on the Earth. The second question I have is, how does the projected coordinate system, PCS, handles the Earth's shape? The answer is it flattens the Earth's surface and using Cartesian coordinates x, y, z to locate your target on the Earth. Next question I have is, are measurements on maps with projected coordinate system always true to scale? The answer is no, and this is specifically true when you are having a large area in your project. The reason is because of the distortion from the projection. So when you have a large area in your project and when you're using projection coordinate system, you may need to apply correction factor to correct your measurements. Next question I have is, can NAD83 and WGS84 be used interchangeably for North American projects? The answer is no, although you're getting very similar results from two geodetic coordinate systems in terms of output, but they are different reference frames after all. So when you're doing precision request task in your project, you need to properly transform your data into the desired coordinate system. Next question I have is WGS84 less accurate than NAD83? Not necessarily, because NAD83 is just a specific coordinate system that is more used in North America. But when you're having a project, let's say in North America, using WGS84 to collect all the data, for such purpose, it's not gonna really change anything in terms of accuracy. So selecting WGS84 or NAD83 is only depends on your project demand. And just talking about two different geodetic coordinate system, it's not one being superior to the other one. And the last question I have is, when you capture a photo using DJI Enterprise drone, the coordinate embedded in the image metadata field are based on which coordinate system? And we kind of went through that also. It is going to be Geodetic WGS84. And now that not only applies to photos, applies to videos, applies to, again, LiDAR point cloud data. Okay, with that being said, that's everything about this episode, and I'll see you in the next one.